2 weeks ago when we talked about congruent figures. When we talked about congruent figures, if we had to have two triangles that were congruent to one another, we had to show that all three angles were the same. You had to show that all three angles, the corresponding angles, were congruent. And then the corresponding sides. You had to have 6 total things for triangles, 3 angles, 3 sides. Well, as we go along a little bit further and further into this, we start to take away some of the necessary pieces. For example, today we're going to talk about one way that you can show that triangles are congruent just by showing that all 3 corresponding sides are congruent. Okay. We'll talk about 3 corresponding sides. We'll talk about 2 sides and an angle. Tomorrow we'll talk about 2 angles and a side, the side after the angles, or the side between the angles. But notice, if you look at all the acronyms we have up there, we have side SSS, SAS, AAS, and ASA. What don't you see? Correct, because there is no ass in math. You can all say it. No. There's no ass in math. Because it doesn't work. Because when you have if you have an ass in math for showing that triangles are congruent, you have what's called the ambiguous case. It doesn't always happen. Sometimes it works, sometimes it doesn't. So we just say there's no ass in math. So as silly as that sounds, if you ever write down that triangles are congruent because of ass, you're wrong. Because there is no such thing. Write that down. There's no ass in math. No ass in it. There's no ass in math. So anyway, what we do today, we're going to talk about this thing called side, side, side. If the 3 corresponding sides of one triangle, I should say 3 sides of one triangle, are congruent to the 3 corresponding sides of another, the triangles are congruent. Okay. It's a shortcut way to show that something's going to wind up being congruent. Basically, you just have to have all 3 sides congruent to one another. Which means that we need to keep track of what parts we're working with. So usually what I do, since we're pretty reliant upon our progression sheets, I like to dedicate a square to how to prove that triangles are congruent. So let's get our sheet out. And what I want to do, like I said, I want to dedicate a square to how to show that triangles are congruent. How to show triangles congruent. Make sure you save yourself some space. Because like I said, there's going to be 5 total. We're going to continue to list out into the same square. Okay. And like I said, one of the ways that we're going to show that triangles are congruent is called side, side, side. And it basically means all sets of sides are congruent. Corresponding sides wind up being congruent. I'll show you what I'll do on the sheet here. Again, ways to show no, I'm just writing it down over here as well, and that we can see it a little better. It's quite literally means all 3 sides are congruent to the 3 sides of another. Do they all have to be the same length? No. Could they be? Sure. Can two of them be the same between two triangles? Absolutely. I mean, like, let's say both sides are 8 and the other one's a 5. Sure, that could happen. But the idea is all three have a correspondence. And that's how you consider the triangles. It is a very, 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 very straightforward thing. The other one we're going to look at today, yes, ma'am. Yeah, it's just dash. S, side, side. It's called side, side, side. Okay, it's called side, side, side. And we just put a dash between it because it's the common way that you'll see it written in textbooks. They've usually used the little hyphens there. The other way that we're going to look at today is called side angle side. And what happens with this, is notice the lettering. Where's the A value in the lettering of side angle side? It's between the two sides. So when we have side angle side, you're always going to have the angle between the two sides. That's why they say side angle side. It's always going to be the angle between the two sides. That's what that means. It's called an included angle. It's the angle between the sides. Included angle. It's the angle between the sides. Yes, sir. Yes, sir. Because it tells you which one you have. If you've got all three sides, you've got side, side, side. You have an angle between two sides, side, angle, side. Tomorrow we'll talk about two angles, then a side, angle, angle, side. Angle, side, angle would be the two angles, side in between. That's how the lettering goes. That's why we use those acronyms. Right? The included angle is the angle that's congruent between the two sides. Again, as we go through, it's going to be really, 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 really easy to see what this looks like. It's going to be super simple to see. Okay? There really is no trickery. Well, try not to, at least. Okay? We all right on those two? Well, let me get going here. We'll get you some examples and show you how actually simple this really is. Because remember, everything that we've done thus far, as far as progressions and stuff are concerned, we still use the same ones. Given a midpoint, what do you say? Oh, I got two congruent angles. If I have an angle bisector, what do you say? Oh, I got two congruent angles. You know how to do all the rest of it. It really comes down to drawing and marking diagrams. If you can stay consistent with that, this is a cakewalk. For example, let's do this. This is what a triangle proof will look like. We still have a given and a proof statement. So what will happen here is we'll get these things that look like this. We still have a given and a proof statement, but instead of proving something algebraically, twice this angle or twice this segment equals this other segment, there's not as much algebra to it, where you're going to be doing angle plus angle equals 90 and substitution and all that kind of stuff. A lot of this is just becoming, what definition do I have that I can mark my diagram to show that's congruent to something else? Things like that. And like I said earlier, traditionally, these first few days are much easier than what we just finished. Okay? It's much easier than what we just finished. There's not as much you have to know. But remember, every progression sheet. You should never lose your progression sheet. Okay? So when we have a diagrams like this, not always will they be already pre-marked. Sometimes you actually have to mark them. But when we start to do our proofs, we just kind of go with the idea of, well, statements and reasons, just like normal. And you start. LM is congruent to NP. That was given. LM is congruent congruent to NP. The diagram is marked. There's no progression from that. There's nothing else that I can say about it. There's no definition attached to just saying, hey, these two things are equal or these two things are congruent. That means I just go to my very next statement, just like we did before. Again, my diagram is marked. As of right now, I've told you guys 2 different ways that you can show that triangles are congruent. Side, 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 or side, angle, side. But if we look now, look at your progression sheet and look at the diagram. What other information can I infer from my diagram according to your progression sheet? How? Does it say that's a rectangle? Okay. Does it have to be a rectangle? And that's the thing, you can't assume it. Because remember, there's no in math. There's no ass in math, right? You can't assume stuff. The only thing you can do is you can infer from the diagram. Look at your progression sheet. When you look at your progression sheet, there should be a square that tells you about something that I see in this diagram. Okay, they share a side, right? What's the side that they share, guys? ln. They share ln. What is that called when you share a side? What's reflexive property? Now, when you have that shared side, according to your progression sheet, it said if you have a shared side, you have to say that it's congruent to itself because of the reflexive property. Reflexive property, however you want to write it. Now, do you have 2 triangles that are congruent? Yeah. You have all 3 sides marked up now. Now you can say triangle LMN is congruent to triangle NPL because of side, side, side. All you're doing is using the given information, marking the diagram, and looking what else you can do. It isn't. You're going to use reflexive a lot because of shared side. If you have a shared side, you can say that from the diagram. So, how many total steps are there in this one? Total things you had to write down. Times 2 is 8. There's 8 total. That's what I mean by that. There's 4 statements, 4 reasons. Okay? There's 8 total things. Of those 8 things, 4 of them were given to you. Right? The 5th one was also given to you. If you really think about it, this last bit here had to say that the triangles were congruent. So right away, 5 out of the 8 things in this proof, you didn't even have to think about. You know over half the proof without doing any thinking. You get going into the rest of it. You're looking at a diagram. On your sheet, it says, hey, knucklehead, look for a shared side. Oh, that's that one right there. I can say that's equal to itself. I didn't have to think about it because I'm just referencing my paper. So as you get to that, now that makes it 7 out of the 8 things you really didn't have to think about right now. The only one you had to think about then was, which of the 2 that I know how to prove triangles is it? There's no reason why you can't get every single step, every single piece correct, because you have all of the information in front of you. That's the idea. Can I reference my material to get this correct? That's what we do. We just go back and forth, back and forth, back and forth. Okay? Like we said, it's not that bad, was it? Let's try another one. Let's see how this one will do. Let's do one that actually has a progression. Okay? Take a second, write this one down, draw the picture. take a minute, draw the picture. Finally getting people caught up on taking stuff. All right, we got this drawn up so far? Okay. What do you think the first thing you're going to write down is? The first given. AB is congruent to CB. And then I mark my diagram. Is my diagram already marked? Okay. Is your diagram marked? Good. All right. Is there anything else I can do from that given statement? No, nothing else. No definitions tied to it at all. I just continue on. The next thing it says that D is a midpoint of AC. All right. What does your progression sheet say to do if you're given a midpoint? What does it say? Segment equals segment. Now, do I want to say equal or do I want to use congruence here, you think? Yeah. Now, since I'm not doing there's no segment addition or anything like that with any of these, I'm just going to do congruency. So anytime I have, what do you call it? Midpoint or angle bisectors, I'm going to use segment congruent to segment or angle congruent angle. I'm not going to worry about saying that they're equal. Okay. So here, what are the two segments that are congruent to each other if D is the midpoint on AC? All right, so I know that's what it's going to be. I immediately mark my diagram, and then I write it down. AD congruent DC. Reason? Definition of a midpoint. Okay. After that, we have to show that the two triangles are congruent to one another. Well, I only know two ways of doing it. Side, 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 or side, angle, side. Is there any way I can figure out that angle A and C are congruent to each other? No, which means I have to use side, 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 which means what's left for me to say? Reflexive property again. Anytime you see a shared side, you know you're going to have reflexive property. I know that I can say DB is congruent to DB because reflexive property, reflex property, or reflexive property. And then I mark it. Do you have triangles now? Yeah. Yes, sir. That's okay. That's okay. The only thing I would stay away from doing that is what happens if you forgot to write that down. That's the only reason why whenever I have something that has a progression, something that I have a definition for, I use it right away before I forget. But if you did it out of order, it's okay. All right. It's just a reminder just to try to, as soon as you say you have midpoint, use it. All right. So now, do you have triangles? Yeah, just write it down. ABD, CBD. Triangle, ABD. And what's the reason? Yep, side, side, side. Okay. Now, break it down further again. There's 10 total steps here. Of those 10 steps, the first 6 were off of givens. So, bless you. And you're just allergic to this class today, aren't you? So those first 6 steps, 60% of this whole proof is off givens. Okay? You go to that step at the very end with the ABD. That's 7 steps. 70% of the proof is basically handed to you. You just have to write it down. The other parts, well, it's reflexive. That's on a progression sheet. And then you just have to make the one decision. What way are those triangles congruent? So if you really, really, really get into this, 10% of this proof, one part, was the only thing you had to really think about. Which one is it? Because you had to mark your diagrams. So 90% of all of this junk on there is on your sheet of paper. And even really that last bit is on there. You just have to figure out which one it is. There's no thinking involved here, guys. It's what information do I have? What do I write down as far as what right? All right. You guys do this one. Take 5. What was the first thing you wrote down? Yeah. B is the midpoint. Thank you, sir. You're much nicer than I was. I would have given her a math talk. So if B is the midpoint of AE, what do you do to your diagram now? Mark it. What are the 2 segments that are equal? B is the midpoint of AE. AB and BE. Perfect. We mark it, then we write it down. I always like to use my givens first. Like if there's something I can do, I write it, then I go to my next one. And then I go to my next given. If you did it out of sequence, if you wrote down you still have both sets of midpoints. It's okay. But like I keep telling you guys, eventually when you have 5 or 5 givens, if you forget one progression, you're going to get screwed up. So I just always use the progression if I need to. Next one was B is the midpoint of CD. So I go to the diagram again, and then I'll notice what 2 segments are now equal. Yeah, CB and BD, or DB, BC, however you want to say it. Those 2. We mark it. We write it down. DB. Again, definition of midpoint. Okay. I've used up all of my givens. Now I just have to sit there and figure out, all right, there's only 2 ways I can prove that triangles are congruent. You just figured it out. How? How? You're correct. Why? What's the reason? But I want to change your letters around a little bit. What's the reason? What are those called? No. You're right. Look at your progression sheet. There's perfect. Yep. We know those 2 happen. On your progression sheet, there should be a picture that looks somewhat like that. Oh, yep. Bow tie. Look for vertical angles. Hey, look at that. Vertical angles. So now, here's the thing. When you say angle, excuse me, if I say angle A, B, D, watch the tick marks of those. It started with 1 tick mark to the angle, 2 tick marks. The other angle lettering should match. See where I was going? You had the right angles, but you see where I'm going with that? So if I said A, B, D, the correct correspondence has to be E, B, C. That's the tricky part. You just got to make sure your lettering matches up. And we know vertical angles are congruent. And I think that's what we have on our reason map, isn't it? Or in our progression sheet. You can say that angle is congruent to angle because vertical angles are congruent. Do you now have two triangles that are congruent? Is it because of all sides or side angles? Good. So now you can write that down. Triangle ABD remember I kept telling you guys we have to put symbols in front of three letters? This is why we got to put letters in front of three letters, because you don't know if it's an angle or if it's triangle and all that. So you always have to make sure you have symbols in front of three letters. So going through this one, like we have been talking about it this way, there's 12 total things we wrote down. Okay? First 8 of them were given statements. And the first 8 of them were given statements. 8 out of 12, that's what, 75%? Exactly. So if you have no freaking clue what you're doing, if you can follow your progression sheet, you got 75% of that right. What? So Delaney, they're not trying to pick on you. No, I just never had any. But now you know that you can fake your way through 75% of it. Hey, here's a little something to remember. C's get degrees. Anytime you want to smack Joey for like if he's harassing you, just smack him. I know it's okay. I'm not going to say that you should hit him because he probably deserved it, and it's okay. So he's like, what? I didn't mean to do it. But no, seriously. And I'm not poking fun at you. I'm just saying in general. If you have no idea what you're doing, use your progression sheet because you can fake your way through over half of it. Okay? Seriously. You should be able to get through over half of it. Now, if you go through here, think about it, there's 8 out of the 12. Vertical angles. Isn't vertical angles a picture on your progression sheet? Okay. So there's 10 out of 12. Isn't telling you what to prove 1 out of the 12? Again, it goes back down to there was really only one thing you had to try to figure out. A lot of times. Because a lot of the stuff is here. You just gotta find it. That's why I tell you to rewrite this every once in a while so you remember where things are at. Okay? One more. This one has a perpendicular progression. If you've got perpendicular, there are 2 things you can say off of it. Okay? Try that. It's BD is perpendicular to AC, and then AD is congruent to DC. Prove the 2 triangles. I gotta stop using green. It doesn't show up very well. Green. The light is just enough of a. what to do. Yeah, you give them perpendicular. Yeah, it's right angles. Where the right angles are. Okay, use 3 letters. That's a segment. You're going to name the leg angles. How many letters you have to have for angles? How many letters do you use for angles? Right. So what are the 3 letters that you have for angles? What's that? That's up here then. ABC is up here. That's a straight angle. Where's the right angle? Draw the picture of where the right angle is. All right. What makes this right angle? Okay. What letters make up? What are the letters in that? Okay, that's BD here. That's just one. You use 3 letters. What's the angle? You're overthinking it. You need 3 letters for an angle. 3 letters for an angle. What makes it up? What are the sides of that angle? 2, D, and the D to. That goes straight. You have to go up. So what are the 3 letters? Hallelujah! Hallelujah! What do you got? Draw the pictures. Mark the diagram. What are the angles that are formed? Okay, so what are the angles? Perfect. You got it. Guys, here we go. Given BD perpendicular AC. Guys, look at your progression sheet while we're doing this at the same time so you can you make sure you have this written down correctly. If you're given perpendicular, it says state the right angles that are formed. Well, like Ethan was doing here, he went to his diagram and he said, all right, I know they're here. Okay, name them. Follow the letter. You've got 2 angles that are created now. You've got angle ADB and angle CDB are right angles. I named them. Okay. I know, just like you said, you knew that there were 90 degrees, right? And that's in your circled area. That's why I said name them. Mark the diagram so you know which ones you're working with. Once you know those 2 are the right angles, according to your progression sheet, I forgot right definition of perpendicular because that's what it says to do. After I know that I've got right angles, my sheet says those right angles are congruent. So then I write down angle ADB is congruent to angle CDB. Because, according to the sheet, all right angles are congruent. They do. I'm not there yet, but yes, you are right. They have a shared side. So what I've done there, I've just used the progression of perpendicular. Perpendicular says, if given perpendicular, name the right angles. Then say that those right angles are congruent to each other. Following the progression. Right. Now I go to my next given. My next given says AD is congruent to DC. And I mark it. Now Cole just said something here a second ago, and he was right. What was it that he had said? What's the shared side? BD. Everybody see that BD shared? What do you call a shared side again? Reflexive. So how do you write that out? You just say BD is congruent to BD. Reflexive property. And now you've got your triangles. I forgot what the letters were. ADB
because of side angle. Now, I already posted the 4 problems I wanted you guys to do tonight. There are 4 proofs of this complexity. There's nothing more than six steps on either side. Okay. I want to say it's on page 230, I think. I think it was page 230. I think it's 230. It was 9, 10. Is that right? Is it 14, 13, 14, or 15, 16? It's something like that. I know it's on the calendar. At 9, 10, 16, 17. So there's 4 of them. You get all those on one sheet. Draw the picture. Mark the diagrams as you go. All right? They should not be horribly difficult. They really shouldn't. Okay? Just follow your steps, ladies and gentlemen. Follow the steps that tell you to do. Enjoy the afternoon.